Finding normal values on your calculator. Now this is completely optional. If you are more comfortable with the tables, they will be provided, and you're welcome to use that, but it doesn't hurt to learn how to do these on your calculator. So going back to example 2, we were looking for the area to the right of z equals 0, and we already know that one. That one is area 0.5. Let me just show you how to do that on your calculator. So your distribution, similar to where your binomial distribution was, is under distr here above your variable button. So if I hit second variable button, I get this. And again, you have two functions, normal PDF and normal CDF. Because we're looking for a span, an area between two values, even into the tails, this is going to be CDF, which stands for cumulative distribution function or density function. So make sure you choose number 2 every single time that we're doing this. So the normal CDF. Again, with the calculator, you have to know the argument, and you can't just kind of type in whatever you want to. For normal CDF, the argument is the left bound, meaning the leftmost point that you're considering, comma, the right bound, comma, mu, and sigma. If you leave mu and sigma off, your calculator understands it to be standard normal, where mu is 0 and sigma is 1. So thinking about that first problem to the right of z equals 0. Well, that means I go from 0, that'd be my left bound, into the tail. And technically the tail continues infinitely, but I'm just going to put 99 because that's going to be plenty big, and you can put 999 if you want to. And because it's a calculator, it generates this value algorithmically, I believe, so we might not get 0.5 exactly, but let's see what happens. So it's right of 0, so 0 to 99 or 999, and that gives us, and that's pretty much 0.5, 0.499999. So that's that 0.5 we were expecting. Now the left of z we had earlier, left of z equal to negative 0.47. So if I did that same thing, remember we're choosing CDF for cumulative. If I'm to the left, that means my tail goes into negative infinity. So I'm going to do negative 99 or 999, however large you want to make that, comma, I go up to negative 0.47, and I'm not going to bother to type in the mean and standard deviation because they're 0 and 1. And something, oh, I know. Here's something to be very careful of. Your calculator has a distinction between negative and minus. So this sign right here, that's why the cursor's there. It's saying I don't like this. Make sure you use the negative down here. Notice how much it's smaller and not the minus sign. Let's see if that works. And there's that 0.319 that we got previously. So a lot of those are going to be similar. Here's one that if you jump down to E that we did, so second distr, number 2, that one said between 0.32 and 1.92. So that's my left and right bounds right there. So 0.32, comma, 1.92, and it looks like, and I'm just catching this, it looks like in the notes I transposed the 9 and the 2, and I worked the whole problem doing 1.29. So let's see if we get the right answer doing it that way. So second distribution, normal CDF from 0.32, comma, to 1.29, since that's how I worked the problem, and that's the 0.275 or 276 that we got earlier. So no matter what the numbers are, if you're going into the tail, use something big like 99 or 100 or 999. But if you're going into the left tail, make sure to use a negative number. If the right tail, it'll just be positive. And we also had example 4 when we introduced our probability notation. So for A, there we had probability that z is less than 1.2. Well, that means I'm going into the left tail, and we had a picture to show that. So I would set up -999, comma, up to 1.2, and 0.8849. Then we also had for part B that Z is greater than -1.5. So that means my left bound is -1.5. Into the right tail, so that'd be +999. And that's the value that we got before. So all of these standard normal values you can find in your calculator, but you still have to know what's going on. You still want to be able to draw that picture to know if it's the tail that you want or the bigger area and that sort of thing. So still important to draw those pictures. Finally, we had where we were working backwards. So we knew the percentage of the area, but we didn't know the z-score that gave it to us. So your calculator can also help with that. If you go back into the distribution menu, number 3 is inverse normal, and that's what we want. For inverse normal, the argument's not too complicated. You just want to type in the percentage. So for example 5 part A, we have 55% to the left of Z. So I'm going to type in 0.55, and it gives me back 0.125, which we got previously. For part B, we had 8% of the area to the right of 1.4. So we go in and get our inverse normal function, and I'll type in 0.08 for 8%. And it gives us -1.4. Again, this is where you need to know which side of the graph that you're on. The calculator's assuming that your area is going to the left, and your picture might not look that way. And specifically in part B, we were told that the area is going to the right. Now the numerical value is still right, the 1.4, but you as the student need to know, is it positive or negative, and you can only get that if you go ahead and draw a picture. So don't just automatically write down what your calculator gives you. Make sure you understand what your calculator is giving you. And on part C, another little mistake that I made, when I divided 0.05 by 2, I threw in an extra 0, so it gave us a different value than we were supposed to get. We should have been doing 0.025 rather than 0.0025. But again, if we do inverse normal, and I do 0.025, which is the area in the tails, I get 1.95, or you can round that to 1.96. And this is where we were between. So I would have two values this time. I'd have -1.96 on the left and +1.96 on the right. And finally, the last one we had in example 6 was z sub 0.01 with the alpha notation. So again, I go into my distribution menu, 3, and I just type in that 0.01, and that's what we got before, but just double checking to see which side of the graph we're on. So those are some calculator steps you can do. Again, it's up to you if you prefer to use your calculator or if you are more comfortable with tables.